motors and fans, oh my, tools even. What are we doing today? Well, this is my third take, partly because of my neighbours being noisy, but I've decided today I'm going to upgrade my ventilation system. Now this piece of ducting here, this goes up to my window, to a piece of core flute and an 80mm computer fan. Now I have a huge box of those, and I should have probably brought one in to give you an example of what an 80mm computer fan is. But then I thought that it's probably not worth my walk to the shed, because most of you guys, if you're watching my channel, you've probably seen an 80mm computer fan before. So I've decided I want to do something ducted. And so I've had a scrounger in my shed, had a look at some bits and pieces to see what I can do. And I found this piece of acrylic tubing. It's not quite the right size, but I think I can adapt that into the hole. Some of the other things I was given from Leonard Audio, donated some of these motors. I'm not sure what they were used for, but they've got some significant horsepower. So I've taken a disc here of approximate size, probably a little bigger than what I need. I'm planning on making a compressor style fan, something similar to what's inside a vacuum cleaner. So I thought this might be a good test to see if these motors will have the horsepower required to do that. For scale here, here's the acrylic tubing. But this I'm hoping will give a little bit of an indication of whether or not this motor will do it. So I'm hooked up here to 12 volts. Don't mind my shaky hand. I suspect that's a result of MS. I have multiple sclerosis. It could be a number of other things, but we'll get to that eventually. That's a doctor's job. Let's fire this up at 12 volts and see what happens. Well, I think this probably has enough horsepower. It's certainly going very fast. The vibrations have been enough to shake the blue tack off the top of my desk. And of course, blue tack, true to form, comes down with junk stuck to it the moment it touches carpet. Probably not the best choice for flooring in a workspace. But anyway. So I think these motors will probably do the job. I can probably dual drive it from both ends if I need more horsepower. So I think we found our motor. Now to figure out how we're going to make our impeller blade. I don't know if I'm going to 3D print it or whether I'm going to laser cut it. I'm trying to figure out at the moment, the impeller blade style that I'm thinking about doing is a centrifugal fan, or a centrifugal, however you want to call it. So it would intake in the middle and outlet to the sides, which would mean I'd have to put multiple baffles down here. I may, on the other hand, try something like a multi-bladed compressor fan, a little bit like a jet turbine. However, that might not be applicable when I'm driving it with a motor, rather than having an ignition chamber between the two compression stages. So I'll have a bit of a think about the fan blade I'm going to do here, and then we'll probably either 3D print or laser cut something. I'm not sure yet. So I'll try... I'll come up with a few ideas and we'll cut to the ideas I've got. Alright, I've been having a bit of a brainstorm, and I'm figuring that a fan of about this diameter will probably do the job. Rather than going down the centrifugal path, I've decided what's going to be probably more practical and easier is just a single bladed fan like this. And I've taken the top off a bottle just to create myself a temporary fan design, just to give an idea of how well a motor of this horsepower will turn a fan of that kind of magnitude. And I'm guessing, I've made a very, very loose assumption that this will be about the same weight as the 3D printed fan that I'm thinking about making. So this is just purely a test to see if the motor will handle it, and maybe a loose idea of what airflow I might expect. It's not going to be perfect or balanced by any means, but let's see what happens. Alright, well, it did work quite well, but clearly my motor torque has plenty, or my motor has plenty of torque, as it's chewed out the top in that short space of time. But while it was running very quietly actually, and moving a lot of air. So I might give this another crack. I'll just have to find a way to secure the motor. Let's have another go. Alright, so some super glue, some hot glue, some smearing, and a little bit of sewing machine oil later. I have myself a new fan connection. Now, righty's a little shaky at the moment. Oh, it's still connected. Alright. Always connecting's first. A little distracted by the neighbours at the moment, so probably doesn't help matters all that much. But we live in a society and I've got to live next door to people, so what can you do? Live out bush. Actually, a few of my friends do that, and it would be very tempting if it wasn't for my apprentice. Anyway, let's get this thing fired up. Let's see how much air it can move. Well, it moved quite a lot of air until it chewed out the fitting again. So I think conclusion for this is probably these motors have got more than enough torque to run the kind of fan that I'd like to run. And that was moving very much more air than an 80mm fan or an 80mm computer fan. So let's move on to the proper thing. Alright, we have a finished 3D print, although I ended up with a 4mm hole instead of a 2mm hole in the middle. That's a trap for AutoCAD when you're drawing circles. There's also a lot of standoffs in here that need to be cleaned up. Now that center hole will be easily fixed. I'll fill that up with something, then I'll print another one. And there's also this original brim that needs to come off as well. So I'll do a bit of cleaning up and we'll be back shortly. Alright, so I have my 3D printed fan and all the junk that I've just snapped off it. Now, at first glance, I'm thinking that for a start, I'm going to have to reprint another one either way because I've got the center hole wrong. And you can see here that even with a bit of hot glue, it's nearly impossible to get that center. So that's one thing I'll need to fix. The other thing is with this fancy blade profile I chose, my printer wants to put a whole lot of standoffs in there, or at least my slicing tool, and that's making for a very uneven surface, which is going to make for an inefficient blade. So that I might end up, now that I've just wasted like 2 or 3 hours, I might even go back to my laser cut idea. But let's give this a run and just see how we go. Let's fire this up at 12 volts. Well, it's certainly moving some air. I better get out of the path of that in case it breaks. It's certainly stringing some air around. Let's see how much current it's pulling. I'll point this up at my current meter. Okay, so over in the blue is the current meter. Now this is with the overhead lights running. I can turn that off, and so we're pulling about 0.6 with the lights off. Let's fire this up. We're pulling about 1.8 amps at 12 volts. That's quite a bit. And it's pulling the current down a little bit. And it just got loose and flung off across the room. So I have no blade anymore. Well, I think laser cutting is probably going to be the option. So, back to the drawing board. Alright, so I've been doing a little bit of thinking, and I've been through my whole workshop and my huge box full of fans, and I come up with a few crazy ideas. One of which was to try and like double or triple stack 80mm computer fans. You've seen that idea as well. And then I found this. This is a little mini evaporative air conditioner, and I use this for something like, well, actually I used this for 7 out of the 8 years that I've been doing fire spotting work, and the MS may have got the better of me this year, so it may be that when summer rolls around I'm not doing that anymore. Anyway, the story about this. I went to take it on a camping trip at one point, and I normally take the battery out of this, which is a 6-volt gel cell, and run it off the 12-volt DC input. Well, because I got lazy, I used a lead with a couple of clips on the end, and I plugged it in reverse polarity. Now, I've been waiting to fix this for ages, and I haven't gone back to it. I found that a 120mm fan over my bedhead probably does just as much as this. I'm thinking that given the amount of time that this has done me, I probably don't owe it anything, or rather it doesn't owe me anything. So I might extract the fan out of it. It has a very nice big high volume fan in there, and that draws a lot of air through, and I might even be able to reuse the housing. So I'm thinking this might even, I don't know, I'm going to have a look inside it, see what damage I've done to the circuitry, because I haven't looked at it since I blew it up. It might be repairable, and I can make a cowl to fit directly on the back. And then I might be able to run water through, and it might be able to filter stuff out. Anyway, we'll figure it out. Let's have a look at what's inside this first. This might be the answer to my problems. Okay, so we have the unit open. Let's have a bit of a look at the fan section here. So this is our big barrel fan. Now, looking down here, we have our motor, which you probably can't see on camera. It's made by the Yongyiho Electronic Limited, and it's a DC 6-volt. So if I do use this, I'm going to need to regulate it down. Now, straight away, I see this inductor here has had the crap melted out of it. That's quite likely, considering there's a diode. So when I've reverse polarized it, that diode could have caused DC to flow through that inductor, shorting it out. I don't know. More than likely, it's probably just this little regulator chip here, which is a U401. What actually is that? Let's have a look and get some light here. So that is an XL2596T. Not sure what that is, but this does have digital speed control in it. And I'm seeing a host of surface mounts here, so there's a good chance this is probably not really worth fixing, but let's just pull these boards off and have a look. Alright, so I had a close look at this board and tracing the plug that went to it. This appears to be the volts in from the 12-volt DC socket in the rear. So let's have a flip over here and have a look. So our volts in comes in the top here. We have obviously ground is a common ground. And our positive line runs all the way down straight into that chip. No protection, no nothing. The diode appears to be across that, so it appears to be across ground and that wire there. So that diode we assume should be short circuit protection. However, if that's blown up and then things have then become short circuit, this chip will have been reverse powered directly. So I have a feeling that most of this probably would have been contained in that chip. This looks like to be a charge circuit for the 6-volt battery, which has never really been used. Big hefty power diode and a couple of resistors and a little ceramic capacitor and a couple of electrodes. So that I think is probably a charge circuit. But this plug here, I'm pretty sure I can plug 6 volts directly into that from a variable supply, and we'll see if the rest of this fires up. And if that's the case, then this board is relatively simple to repair. So let's see what we can do with an external supply. Alright, so I attempted to feed 5 volts instead of 6 directly into this input, polarized as indicated, and I did check. Well, my voltmeter didn't actually show voltage, which means it had pulled the voltage way down below 3 volts. And then I started smelling hot resin. And now, where I put my finger on the board here, there's an exceptionally hot bit. And I also smelt what sounded, or heard what sounded like a component dying. I now notice that there's a track lifting under here, so I've probably destroyed something bigger than I realized. So let's just lift this board up and have a look. So there's a push button under here. There's a big fat resistor. One of these feels warm. And there's a fuse on the board, which appears to be blown. Let's get the multimeter and test that. We'll jump down to continuity mode. Put 12 volts on. This has dropped down to about 3 volts through my tester. Let's get into this fuse under here. Fuse is indeed blown. Maybe that's what blew. Maybe it's just a blown fuse. But I'm also not really keen to put this back together. A lot of the waterworks and the pump and everything have all seen better days. Oh, and there's 2 more LEDs up here. Oh, these will be the white LEDs for the display. And I never knew it had a blue LED either. That's new to me. Alright, what I'm going to do, this fan, everything has got connectors on this board, so let's pull a connector off. I want to find the power supply direct to the fan motor and see if I can do that. Let's undo this, because this is pretty much a salvage job. I'm not really that interested in reassembling this. And let's just fly over to the pump, and this will indicate why. So the pump has seen plenty of days. I'm not so sure I want that pumping and vaporizing water into my air. The other thing that is probably worth noting is this is the evaporation filter from the back. It's also seen better days. I should note that this started out as a nice clean white color many years ago. It's now turned a funny brown. I think partly because the town I live in has bore water as its main supply during the summer, but because we've had a couple of years of drought, we're now seeing that happen in winter. So anyway, I've removed this little twist tie. This appears to be the power drive direct to the motor. Now I wonder if this is going to be a PWM driven motor, in which case I do have a PWM output. But the silk screening on this board is in Chinese, or no, this looks like Japanese hiragana or katakana. I don't know the difference, to be honest, so I'd best not speculate. But we have a 5 volt output here. So what I'm going to do, rather than blow anything else up, I'm going to connect it just gently, just touch it. So let's turn on our 5 volts. Let's just give this a little touch. Haha, it is a DC. Alright. It works. Okay, so I can salvage this fan rather easily and do away with the circuitry. And I wonder if I can maybe feed it maybe 9 volts. Let's just try it quickly on 9 volts. Even though it's rated for 6. So let's go up to 9. Just a little bit, or 8.87, whatever. Well, that really moves some air. That might do my job. Alright, Well, for that matter, I could probably add just a variable current supply on it. But I do have a little motor speed controller, so we might even try that. For now, I'm going to get this fan unit out because I think it's going to be more useful for fume extraction than it's going to be for evaporative air conditioning. And I am a little hesitant because these things go for about $100 each. But I'm pretty sure I could get something out of China of a similar quality for a lot less. Let's get this fan out. Now I have to excuse some of the wind noise. It's a windy day today and I'm ventilating my room with the window open. Now, one of the other reasons I don't like that fan being used again is the mess that it leaves behind on the desk. Although some of this might be super glue, or it might be apprentice hands. I think there's some little tiny fingerprints here. Anyway, we got the fan out. This is going to be interesting to work out how to implement, but I might have to come up with some cowling for this. Right, so I've retrieved what I did have in the doorway, or window rather. I had one cowl for my intake fan and just simply an 80mm fan for the outlet, and I had a little flap to sit over that would blow up out of the way as the air was turned on. That stops a bit of rain blowing back through, but this looks kind of dodgy. I don't really like the way this looks. It's far from ideal, so we're going to chuck that in favour of transparent core flute, or opaque at least. It's about the right width. It's an offcut that I had. It also doesn't look perfect, but crucially it'll fit the fan we want. And because I'm in a rental place, I can't really make anything as a permanent fixture. And my landlord seems to be quite fine with gaffer tape, but not with screws and glue and crazy stuff like that. Took a little bit longer to find than I hoped, but I have a permanent marker. So I'm going to say, I really want to pull that probably over that way a little bit. So we'll just put some marks in here. That's roughly where I want that fan. And we'll get a bit of an idea of its overall duct width in here just by shoving a Sharpie in here. Nobody's really going to see this except for me, so I'm not too, well, now that I'm putting it on YouTube, maybe everybody will see. But just getting a bit of an idea of its overall venting in here. I'm not too worried about the finish, that's what I'm trying to say. Somewhere about there, I will drill those holes manually. So I've got my primary vent measured and cut, and as you'll see here, I'm leaving this flap attached at the top just on one section of the core flute. You can do some pretty nifty things, but this means when the air flows, this will push open. If there's any airflow back, it'll push shut. I'll probably put a few perforations here to make this a little bit more readily movable, but that means I can also put a weight on that so that it just statically stays shut unless there's some airflow. The next step will be to mark out the screw holes and get it attached. And in the meantime, I'm going to cut out the grill for the 80mm fan. Right, I'm going to wait till my neighbour's car drives away because I've just tried 6 takes at this. Alright, so I have the fan attached and I have my fancy little flap and some angry looking spiky self-tappers through, but we'll do something about them later. I have the flap here. Let's test this out. Alright, here's our fan running, and we can see that the flap pops out with the airflow. We can open it up. Microphone kind of windy, and it's going to work alright. The next step now is to cut some more core flute up and make a cowling adapter for my venting. So yeah, alright, that's going to work well, but I think given that I've taken 6 takes at this, it's time for some lunch. Alright, I've got some core flute bent around the corner and a curvature cut to match the size of the tube. And so from here, I need to make a bit more of an adapter to cover up this gap at the top, but we're making headway. Looking like my kid's kinder here with all the tape and core flute. Right, we've got our pipe attached. I used the section of core flute that I cut out to block up the top half of this pipe, and I've used more tape than a kinder on Monday, but it's going to stay there. I think it's on pretty firmly, and I'll do something about this flap and these screws in a bit, but it might deter people tampering from the window from the outside. But yeah, I need to put a weight on this flap so it auto recloses. Other than that, we're nearly there. Alright, so a few days have passed and I've been trying to find a good day where the weather's okay enough to test this. I've decided I'm just going to have to go with it, namely because the weather's just not going to let up. We've got gale force winds that nearly tipped over our fence today, and it's made extracting air from my workshop very difficult. So we're just going to have a crack at this and see what it looks like. And I think at this point, it's also late at night now too. At this point, we're just going to have to go for it. I'm going to take Mr. Stoner torch here and try and demonstrate this. So we're going to start at 5 volts here. We'll see how we go. We get a little bit of flame here. We'll blow this out and get some smoke. So we have a bit of smoke coming through here, and it is drawing it through at 5 volts quite nicely. Let's ramp it up to 9 volts. That's looking a little more useful now. Let's come around at a different angle so we can see what's going on here. I think we can probably see a little more clearly with some contrast against the black screen here. But it is actually drawing the air out, not quite as efficiently as I had hoped, but it's still an improvement on the good old 80mm. And it should suck some solder smoke out, which we can probably demonstrate with a bit of solder. Although I don't think I'm going to worry too much about that at the moment. This works. It'll suck a bit of the fumes and vents away from my nose, and this will suffice until I can either purchase or design something a little better. And as you've probably noticed from the length of this video, my concentration's not the best today. And it wasn't when I started this video, but I'm trying. There's a lot going on in the background that I don't really want to make public. Suffice to say, it's just medical issues that are getting on top of everyone. So yeah, I'll see you in the next one, hopefully when Mr. Stoner Torch doesn't pass out in front of the camera. Hopefully next time it'll be a little more interesting and I'll be a bit more on the ball. And for the record, I'm still dealing with some injuries from the kinder playground, being chased by some kids and fell over on the gravel. So yeah, and that's not the only injury. Anyway, we'll see you next time, and yeah, let me know how crap you think this video was.